Hello, welcome again. We are solving some questions of machine design. The topic is bolts, shafts, rolling and sliding contact bearing. Question number 6 is a shaft made of mild steel is required to transmit 100 kilowatt at 300 rpm. The supported length of the shaft is 3 meter. It carries two pulleys, each weighing 1500 newton, supported at a distance of 1 meter from the ends respectively. Assuming the shear stress for shaft material is as 60 MPa, the diameter of the shaft is option A 66.8 mm, option B 72 mm, option C 63.5 mm, and option D 75.1 mm. So here the power transmitted is your 100 kilowatt or 110 per 3 watt at an RPM of 300 RPM. Length of the shaft is 3 meters and W weight of the each pulley is 1500 and uh, now as these pulleys are supported at distance 1 meter from the end. So this is the schematic diagram. So these are the weight of the this is the weight of the pulley and this is again weight of pulley, and these are the reactions at a distance 1 meter from the either of the pulley. Okay, and this distance is 3 meter. Okay, as it is given, it carries a two pulleys, each weighing 1500 newton, supported at distance 1 meter from ends respectively. So these are the two pulleys at a distance 1 meter from each end. Okay, so as this diagram is symmetric diagram, this is 1500, this is 1500, and this is RA, this is RB. So the reaction will be same in at A and B, and it will be equal to 1500 and 1500. Okay, because of the symmetry of the loading. Okay, and now from the power transmitted in RPM we can find out torque also by using 2 pi nt by 60. So torque comes out as 3183 Newton meter. Okay, so this is the torque, and this is the bending or configuration diagram. From this we have calculated RA and RB. RA and RB are 1500. So if we draw the shear force diagram, we can see that this will be here it is upward, so it will be 1500 upward, and then there will be no force, and then there is 1500 downward, so it will come to that line. The shear force will be 0. So between C and D, no shear force has been introduced, so the line will remain horizontal, and then 1500 downward, 1500 downward, and this, and then 1500 upward. So between C and D, there will be no shear force. So as the shear force is not there, so bending moment will be maximum between C and D and will remain constant, because in whole of the length between C and D, the shear force is 0. So bending moment will be here. If we calculate the bending moment at C or D, then it will be same between C and D. So bending moment, so maximum, and this will, and that will be your maximum moment, and maximum moment will be RA into 1. So RA is your 1500 and 1, so that is bending maximum moment is 1500 and torque is your 3183 Newton meter, and maximum bending moment is 1500 Newton meter. So now from the maximum bending moment and torque, we can calculate equivalent twisting moment. So T is your root m square plus T square. Okay, or it will be 3519 Newton meter. We have calculated twisting moment because here the shear stress of the shaft is given, so we have to design the shaft according to maximum shear stress theory, and according to maximum shear stress theory, the equivalent torque is your root m square plus T square, or it will be 351519 Newton meter, or it is 3519 multiplied by 3 Newton mm. So now this is your equivalent torque, and now using bending equation, T is equal to pi by 16 tau d cube. Tau is given, tau is your 60 MPa, and so this pi by 16 into tau is your 11.8, or D comes out as 66.8 mm. So answer is 66.8 mm. Option A is the right answer.